All right, welcome to 4.2. 4.2 and 4.3 both cover triangle congruence shortcuts. We're going to talk about three of them, well, really only two of them today, and the others when we cover 4.3. So today, triangle congruence shortcuts. Let's talk about what that means. First off, what does it mean for triangles to be congruent? It means they're the same shape and they're the same size. For that to happen, all the parts of a triangle are going to have to be congruent. All their sides are going to have to be congruent to each other and all of their angles. So if I told you these two were congruent and you were to needed to show the marks that prove they're congruent, you'd have to say, well, that side and that side are the same. These bottom sides are the same. Those sides are the same. And not only are all the sides the same, but all the angles are the same as well. All six parts, all three sides are congruent to each other. All three angles are congruent to each other. That's what it means for two triangles to be congruent. Now, the next part is actually saying, hey, back up. The first question asks how many parts did you have to mark in each triangle to show that they're congruent? The answer was 6 because 3 angles and 3 sides. However, this stuff is going on to talk about what if you only had 5 parts marked, right? If all 6 are marked congruent, clearly they're congruent. But what if only 5 of them were marked? Would that be enough information to conclude that these bottom lines are also going to be the same? And the answer is yes. There's no way these bottom lines there's no way these bottom lines are going to be different sizes if everything else in the triangles are the exact same. Those would be forced to be the same size as well. So it turns out when you're trying to find out if triangles are congruent, you don't need all 6 parts congruent. If you have 5 parts, that'll be enough. Heck, if you have 4 parts, if this was missing 2, that would still be enough to force the sides to be congruent. But if you only had, say, 1 part, like if all I told you was that's the only side that we know is congruent, you're like, well, then this triangle that might not be congruent to that triangle. In fact, probably isn't. It's probably, could be something completely different. So there is a sweet spot when it comes to 3 parts. It turns out if you only have 3 parts of a triangle congruent, sometimes the triangles are congruent and sometimes they aren't. So we're going to be focusing our time on those 3 combinations of parts. So 4 parts are always enough to determine a triangle. That means there's only one possible triangle that can be made from that given information. 2 parts is never enough to determine a triangle. If you only have 2 parts congruent, you could have all sorts of different sized triangles. But 3 parts are sometimes enough. So we're going to focus on when we know 3 parts of triangles are congruent to each other and whether or not that'll force the triangles to be congruent. So to do this, we're going to have to list all the different combinations of parts we could have. We could have what we call side, 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 which means we know the sides of the triangles are congruent, but that's all we know. So the 3 sides. If we could know the 3 sides, we could also know the 3 angles. Right? Or maybe I know 2 sides and 1 angle. Maybe I know the angle that's trapped in between the 2 sides. These are the 3 we're going to explore today. We're going to explore if those work for triangle congruence shortcuts. In other words, if they force the triangles to be congruent or if they don't work. The 3 we're going to explore tomorrow would be side, angle, angle, 2 angles and a side, or angle, side, angle, 2 angles and a side, but the side isn't stuck in between the 2 angles, or the last one, side, side, angle, 2 sides with an angle off to the side. These we'll talk about tomorrow. These ones we're going to talk about today. All right. Okay. First up is side, side, side. Side, side, side means I have 2 triangles that have all 3 sides congruent. The question is, would that make the triangles congruent, or could I have 2 triangles that have the same sides but different angles? So to find out if I can, I'm going to take this triangle here, and I'm going to use its 3 sides to make another triangle. And I'm going to try my best to see if I can make a triangle that is not congruent to this one, not the same shape and size. So since I've got my smartboard, I can actually drag these side lengths off. And I can use these side lengths to try to make another triangle. Let's see, I'm going to try to, let's put this one on the bottom to see if we can change things up. And maybe I'll put this one instead of on the right side, I'll have it be on the left side. I'll see if I can make a different triangle. This one was going to have to go out. It's going to have to fit between there. So let's see. If I'm going to fit it here, this one's definitely going to have to go a little bit further outward. So let's try that. Getting closer. And maybe a little bit further outward yet. It's going to have to tilt down a bit. Ooh, I'm getting close. That's too much. All right, there we go. So I made another triangle. It looks like it might be a different shape than that. So maybe side, side, side doesn't work. If it is a different shape, that means these triangles aren't congruent and side, side, side would not work as a congruent shortcut. However, we should probably drag it over and find out. So let's drag it over. You know what? Let's spin this around. Uh-oh. Pull it down. Look at that. Looks like I actually made two triangles that are actually the same size. They are congruent. They overlap each other. So side, side, side. If I've got three sides, even when I moved things around and spun it, I ended up making two triangles that were exactly congruent. That means that side, side, side works as a congruent shortcut, as a triangle congruent shortcut. In other words, if we know that two triangles have all three of their sides congruent to each other, then we know that the triangles are congruent. They also have congruent angles as well. All right. Next up is angle, angle, angle. That means I've got three triangles who have the same angles. So I've got an example here, a 90, a 30, and a 60, a 90, and a 30, and a 60. Those look to be congruent. The question is, would it be possible to have two triangles with those angles and have them not be congruent? Well, I could take one of the triangles, I could stretch it out. That's still a 30-degree angle, that's still a 60-degree angle, that's still a 90-degree angle, but these are clearly different sized triangles, which means the triangles are not congruent to each other. So just because you know all three angles are the same doesn't make the triangles congruent. So that's different from side, side, side. Side, 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 if you knew the sides were the same, those triangles were exactly the same shape and size. Angle, angle, angle does not work, however. I've got two triangles with the same angles, but they are not congruent. They are not the same size. So angle, angle, angle will unfortunately not work as a triangle congruent shortcut. The last shortcut we're going to explore today is side, angle, side. So here I've got a triangle with a side, an angle, and a side stuck between them. Now this is an extra one. What I'm going to do is I'm going to take this same side, angle, and side, right? And see if I can create another triangle that maybe is different. So maybe I could try spinning this around or flipping it or doing something else. But whatever I do, I'm going to try to make a different triangle. And then I'm going to have to add another side to that, right? I can't change the length of these sides because I want the same length side, that angle, and then the same length side. Let me grab my tool here for drawing lines. Let's connect this up. All right, so there's another triangle. What do you think? Is it going to be congruent to the first? Well, if I rotate that around, yeah, that's definitely going to be the same size, right? Yeah, same shape, same size, same thing as before. Turns out if you know you've got a side, an angle, and a side congruent, then the triangles are going to be the exact same size. They will be congruent. So side, angle, side works as a triangle congruent shortcut. In other words, if you know that two triangles have an angle and its two surrounding sides congruent to each other, then we know that the triangles are congruent. The other side is equal to each other and the two angles. So to get how this is useful, we're actually going to do a number of examples to help make this sense. All right, so here's an example of where it's useful. We've got two triangles here, and it looks like we know that they have all equal sides to each other. That would be the shortcut side, side, side. We just learned that side, side, side is a shortcut that works. So if we see two triangles with three sides that are all congruent to each other, we can say, yes, these triangles are congruent. They're triangle, but they're congruent by side, side, side. So far we only know two that work. Side, side, side works, and side, angle, side works. Anything else, we'd have to say, oh, we can't tell. Here's another example. Actually, two more examples. One of these pairs of triangles, you'd definitely be able to look at and say, yep, they're congruent. I know because of some shortcut. The other one, you'd have to say, no, we can't really tell. Can you figure out which? All right. So example 2, I've got an angle there and there the same. Those angles are the same. Those angles are the same. I've got, actually, these angles were the same. But so I've got 2 triangles who have 3 angles that are equal to each other. So this would be angle, angle, angle. Angle, angle, angle was not one that worked. We weren't able to say angle, angle, angle worked. So this one is cannot be determined. Note, I didn't say no, that they're not congruent. They might be congruent, right? I don't know for sure whether they're congruent or not. All I know is I don't know. All right. This next one, example 2, has a side and then an angle and then a side. Same as this side and then an angle and that side. That would be the side, angle, side shortcut. The side, angle, side shortcut works as a congruence shortcut. So as long as I know it has a side, an angle, and a side congruent, I can say yes, those are congruent. So again, recapping, we have 3 shortcuts we learned about today. Side, 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 angle, side, and angle, angle, angle. Out of those, only 2 work. The side, 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 and the side, angle, side. Those work. If we see those, we know the triangles are congruent. If we see angle, 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 we're like, nope, that doesn't work as a shortcut. We can't say the triangles are congruent. All right, here's what your homework is going to look like. You're going to have problems like this, where you're going to have to say whether the triangles are congruent and name the shortcut. So take a look at problem 1. Can you identify which shortcut you would use to say those triangles are congruent? All right. If you said side, 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 you are correct. That's a triangle where I have 3 sides equal to each other. That side's equal. That side's equal. And that side's equal. 3 sides. Now, when I list the congruents, you're going to have to write the congruents. You'll notice here it says triangle dog is congruent to some other triangle. We talked last time when we were talking about congruent statements that the order mattered. So if I said triangle dog, D to O to G, what would be that the same as the triangle on the bottom? All right, if you said triangle net, that would be the correct order. Not triangle 10, not triangle ENT, triangle net. The reason triangle net it would be the correct order is it follows the same as D and O and G. DOG went along this 1 tick mark line and then along the 2 tick mark line. And then it would finish off along the 3rd tick mark line. If I follow that same order, I'd have to start at N, go to E to cross the 1 tick mark line, go to T to cross a 2 tick mark line, and then the last one would be right there. So same order, DOG along the 1 and the 2 would be the same as NET along the 1 and then the 2 tick marks. That order is important, so make sure you write these in the correct order. If what I'm saying does not make sense, you should definitely talk to me during our live session. I will explain it as much and often and in different ways as need be. All right. Oops. So there's our answers for those ones. Okay. Next one. Looks like I've got 2 triangles. I don't know that length or that length. They don't have tick marks. All I know are those angles are the same. Those angles are the same, and those angles are the same. If I were to write a shortcut, that shortcut would be angle, angle, angle. Unfortunately, angle, angle, angle does not work. So I can't say these triangles are congruent. I would have to say cannot be determined. Cannot be determined. They might be congruent, but I don't know. The reason we can't determine it is angle, angle, angle does not work. The other two do. Angle, angle, angle does not. All right. Let's try another one. All right. I've got two triangles here. That one right there. That one right there. Can you say they're congruent? If so, why? The answer? Yes, they're congruent. Triangle ABC, A to B to C, follows along the 2 and then the 1 tick mark, would be the same as CDA, the 2 and then the 1 tick mark. So triangle CDA. And the reason I know it is by side, side, side. Here's one of the sides we know are congruent by those tick marks. Here's another side that we know are congruent because those double tick marks. And the third side, they share, right? They both have that third side. So obviously that's going to be congruent because it's the same thing, right? That third side is congruent to itself. I don't have to list it. We could put 3 tick marks if I want, but they both share that third side. So of course they're going to have the same length. All right. We're going to try a few more of these. Make sure we get it. All right, this one. We're given a couple of congruent angles, and there's actually a third angle I know is congruent. I also know that angle and that angle are congruent. I know that because those are vertical angles, but I don't have any sides congruent. That means my shortcut is angle, angle, angle. Angle, angle, angle doesn't work. So I can't say they're congruent. I have to write cannot be determined. Either we know the triangles are congruent by one of our shortcuts, or we've got angle, 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 and we say, yeah, we don't know that those triangles are congruent. All right, 2 more problems to work through. This one looks surprisingly like that one, right? They both are the same shape. However, this one, we are going to be able to say they're congruent. See if you can figure out why. All right, first off, I'm going to make sure I put them in the right order. Triangle TIM, T to I to M, that'd be the same as REM, right? The blank one and then the 1 tick mark, the blank one and then the 1 tick mark, triangle REM. I'm going to do this in green, I think. The reason I know they're congruent is because I also know these angles are congruent because they're vertical angles, just like last time. And now I have a shortcut where I've got a side and then an angle and then a side. Same thing here, side, angle, side. I know those 2 triangles, the one in pink and the one in that orangish color, those are congruent by side, angle, side. All right, one last example. I can see a side. I can see this is 90, which means that one's also 90 because they form a line. And they both share this side. So that means that's another side. These triangles look like they're going to be congruent by side, angle, side, right? Side, angle, side. So why are they congruent? They're congruent because of side, angle, side. Make sure you list the order in the correct order. This one was listed SPT, S to P to T. That would be the same as L to P to T, LPT, following along that same order, right? All right. We are definitely going to run through some examples like this in our live session, so let's be ready for that. Definitely ask questions if you have them. Today's assignment is a worksheet. It's talking about the side, side, side congruence and the side, angle, side congruence. Again, those are the only 2 that we know so far that work to tell if triangles are congruent. If you end up with angle, 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 that doesn't work.